Last time we ended the lecture with a question. What about if the peak time is equal to the settling time? In this case, who can give me zeta equal to what? Or how to calculate zeta? Or simply, in this case, the percent overshoot will equal to what? In this case, the percent overshoot will equal to what? Can you visualize it? Simply, what I mean, if I have a unit step response, and for sure the system has a peak, let's assume this is the scenario, and it happened to be this one here, that this one is the 2% criterion. So here is the TS, and at the same time, this is the TP, which equal to the TS. So in this case, the percent overshoot will equal to what? Rephrase it again. This point, the value here equal to what? Y here, Y at TP equal to what? No answer? This boundary equal to what? If I need to calculate the settling time, this boundary is what? This one is the 2% criterion, correct? So simply this means that the green dashed line, this point equal to what? Anyone? Someone? No one? Yes.
1.02 أو يعني he made DC game يزيد 0.2.
Just a minute. This one is the line or that draw an envelope which is 1.02 from Y steady state, correct? Yes.
بالضبط.
So simply this point actually is 0.02 or 1. Okay. So this point actually is 1.02 from Y steady state, correct? Yes. So this means that the percent overshoot is 0.02, correct? Or the 2%, correct?
Yes.
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 Yes. So simply from here, I can use تفضل. So from here, I can say that the percent overshoot equal exponential zeta pi over 1 minus zeta square multiplied by 100%, and this is equal to 0.02. So from here, I can calculate zeta. So in this case, if the percent overshoot is 2%, then this means that the peak time is equal the settling time. Good? Yeah, logic? It's logic. And remember, the peak TP here, or YTP, is the maximum point. There's no point above this point. So now this point is actually equal the 1.02 Y state, the 2% criterion. So in this case, the percent overshoot is already given. Okay. Let's discuss another example. Now let's assume that we have the following transfer function y over r, which equal to 1.5 over s squared plus 3s plus 2. And I need to discuss the unit step response. So r of s equal to what in the case of the unit step? R of s equal to what?
1 على S.
1 over s, thank you. Okay, sometimes I'm asking trivial question, but please answer me. Okay, so now before calculating, let's say, okay, find TR, which is the rise time, TP, which is the peak time, TS, which is the settling time. Also, I need to find the overshoot, and I need to find the percent overshoot. Okay. Yes. Now, this system, is this system critical damped, under damped, over damped, or undamped? The first thing. If I need to find zeta, zeta equal to what? If I need to find omega n equal to what? Omega n equal to what? And zeta equal to what? So simply zeta will decide if the system is under damped, over damped, or critical damped, or undamped, correct? Yeah, please. Omega n equal to what?
Over damped.
Over damped. So this will be the square root of 2, huh? Yeah, thank you. And zeta equal to what? So zeta from here, remember, this one has a standard form which states that s squared plus 2 zeta omega n s plus omega n squared. So 2 zeta omega n equal to 3. So simply that zeta will equal 3 over 2 over square root of 2. And if we do the math, this will equal 1.061. This is rad per second, and zeta is dimensionless, has no unit. So the system as Raha, I think. Raha or Rahab?
Raha.
Raha. As Raha stated, it is what? Over damped. Why Raha, the system is over damped?
Because zeta is more than 1.
Yeah, because zeta is more than 1. So simply if zeta more than 1, and simply this is, there's no 0 here. Can you give me the percent overshoot equal to what? Do you, or later I will ask. I will not mix the thing for you. Okay. So now let's see. Who can give me also y still state here equal to what? Y still state here equal to what?
1.5 over 2.
Yeah, it's the DC gain, because the input is unit step, yeah? But if I change the input, you should multiply by the input, correct? Yeah? For example, if the input is 2, in this case it will equal what? 1.5 over 2 multiplied by 2, correct? Yes? Equal 0. Yeah? Now, okay, now what about the error? Who can calculate the error for me? E still state equal to what?
1 minus 0.75.
Yeah, it is R still state minus Y still state, and here it's happened to be 1 minus 0.75. And this, if I do the math, I don't need to be a genius, it will be 0.25, correct? Yes? Yeah? Okay. Now, from here, if I need to find, let's say, the rise time, how I can find the rise time? I need to find the rise time. How to find the rise time? Now remember, our formula for TR was equal to 2.16 zeta plus 0.6 over omega, and this one is valid. This one is valid only for what? For certain range of zeta, correct? This one is valid for zeta greater or equal 0.3, less than or equal 0.8. And simply now zeta is out of this range, correct? So I cannot use it. Can I use it? Can I use it?
لا دكتور
No,
خير
I
يعني
can't.
ما نقدر.
Yeah. No, I cannot use it. Okay. So now what I end up to do, I need to evaluate it, correct? From our understanding of the rise time, which is the time needed for the response to go from 0.1 y steady state to 0.9 y steady state. So simply here, I need to find the response, and I need to find 2 points. One is T1 and the other one is T2, and simply TR is T2 minus T1. And this one will be 0.1 y steady state, and this one will be y state. So what I need in the first stage, I need to find y of t. And how I can find y of t? Simply, I can do the Laplace transformation, or simply this one, it has the standard, let's say, shape of the second order system, except that the DC gain is not equal to 1. So I can write the y of t, which equal Laplace inverse of y of s, and this one will equal 0.75. This is y steady state minus 1.5 exponential minus t plus 0.75 exponential minus 2t, and all of that is multiplied by u of t to ensure that the function is starting from 0. U of t. Yeah, good. So now what I need here, I need to find y at t1 equal to what? Y at t1 equal to what? So simply, this is y at t1. Huh? So y at t1 equal to what? 0.1 y steady state. So this will equal to what? 0.1 y steady state, which will equal, now I will evaluate 0.75 minus 1.5 exponential minus t1 plus 0.75 exponential minus 2 t1. Now y steady state equal to what? Who can give me this value equal to what?
75%.
Yes, so this one is 0.75. So if I do the math, this will be equal to 0.075 equal 0.75 minus 1.5 exponential minus t1 plus 0.75 exponential minus 2t1. Now, if I evaluate, this will equal to 0.75 exponential of minus 2t1 minus 1.5 exponential of minus t1. Then I'm having the plus 0.675 equal to 0, and this is the first equation that from which I can find t1. Yeah, good. Now the second, y of t2. Now y of t2, which here it will be somewhere here, y of T2 will equal 0.9 y steady state. If I project this one here, this T1 and this will be the TR. So TR is equal T2 minus T1. Okay. So y of T2 equal to 0.9 y steady state, which will equal 0.75 minus 1.5 exponential minus T2 plus 0.75 exponential minus 2T2. Now, if I evaluate, in this case, I will have 0.75 exponential minus 2 T1, T2, it's T2 now. Then I'm having minus 1.5 exponential minus T2 and plus 0.075 equal to 0. And this is the second equation that I need to solve in order to find T2. Now, question, how I can solve the first equation and the second equation? How I can solve the following equation? How I can solve this one? And if I know how to solve this one, I can solve this one, of course, huh? Who can give me a clue how to solve the first equation?
ناخذ لين دكتور.
ناخذ لين. Okay, if you take the ln, no. Now see. If we use a change of variable, do you know the change of variable? Which means that you will reconsider how you are looking to the system, or simply you are looking to the system from another point of view. So let's do a change of variable, and for that, let's assume we have x1 equal exponential minus t1. Then exponential minus 2 t1 equal to what? Equal to what? Someone will say it will equal exponential minus t1 all square, correct? Yes? Yeah? So this one equal to what in terms of x1 now?
X1 squared.
X1 square, thank you, x1 square. So now what I'm now x1 square. So now what I'm having, the first equation will read as 0.75 x1 square minus 1.5 x1 plus 0.675 equal to 0. And this quadratic equation, which can we solve with no time, correct? Yeah, we know that the root here x will equal minus b plus minus the square root of b square minus 4ac over 2a. Correct? Now, if I do the math here, I will find that x1 has two solutions, of course, two roots. So the first one is 1 x1 equal 1.316. The second one, x1 equal to 0.684. Now let's see. If I evaluate the first one here, this one is for sure not valid. Do you know why? Because if I need to recover the time, then I must take the ln. Now here I will take the ln. Now if I need to say that it's ln of x1 will equal minus t1. Now you know that here ln of 1.36 infinity, correct? Yes or no? Let's calculate.
calculator 0.27.
Good. So ln 1.3. It's okay. Good. Ln 1.316. Yeah. Sorry. So this one will equal to what? This is my mistake. This one will go to
0.27.
this will equal to 0. If I evaluate, this will equal 0. Now I'll tell you this one is not correct. 0.276, correct? Equal minus T1. So simply T1 equal to what? Minus 0.276. Is it possible? Is this one possible? No, it's not. The time will never be negative, yeah? Can I return back on time? Can I? Simply remember our response is only defined for t equal to 0 and above, correct? So there's no negative time. So this one I will exclude it. So here I will exclude any value greater than 1. Why? Because this will cause the time to be negative, and this is not applicable in physics. So I will end up with what? With the second choice. So here the second choice is ln x1 is equal to minus T1, and here is ln of 0.684
minus 0.37.
Yeah, minus 0.379.
79.
Thank you, Raha. So from here, T1 equal to what, Raha?
0.379.
Yeah. Thank you. And the second, huh? So simply this is what? A correct answer. Yep. So did you understand why I switch out or swing out this value? Because this value is greater than 1, which will cause the ln to be negative, positive. And if the ln is positive, this means that the time will be in negative, and this is not applicable in physics. So I will take the value which is less than 1. What about the second equation? Can you help me with that, Raha? I will do the same. I will do the change of variable. Huh? But now here, what I will say, x2 will equal exponential of minus t2. So this implies that exponential of minus 2t is equal x2 squared. So now if I rearrange the equation, I will get for the second equation, for equation number 2, I will get 0.75 x2 squared minus 1.5 exponential x2 plus 0.075 equal to 0. Now if I solve the following equation, I will get up with 2 x's. I will get the first solution, which x2 equal to 1.946 and x2 equal to 0.0513. Now, which one I will consider? This one is out. So I will consider this one. So from here, I will say that
2.93.
Yeah, thank you. So T2 is equal minus ln of 0.0513, which will equal to 2.591.
2.93.
2.93. According to Raha. 2.93 according to Raha. Thank you. So TR now, Raha, can you calculate TR? TR equal to what? T2 minus T1. Can you do the math for this one? This one minus this one. So this will equal to what?
2.55.
53, huh? Or 35 or
55.
okay, 55. Okay.
Yes.
Second, according to Raha. If there's any problem, please consult Raha. Okay. Okay. Now, What about if I need to find the peak time? What about if I need to find the peak time? Now TB, someone will say TB is equal pi over omega d, and simply because omega d is complex, this means that TB is infinity, correct? Do you remember omega d equal to what? Omega n square root 1 minus zeta square, and now zeta is greater than 1, correct? Yes? Zeta was greater than 1, I think. Where is it? Yeah, zeta is equal 1.061. So if zeta greater than 1, this means that omega d will be complex, correct? Yeah? Yes? Let me ask. طارق أيمن عبد الكريم. زعبي. أنس محمود سليمان فرغل.
موجود
محمد
دكتور معك.
مين معي؟ أنس ولا رزق؟
أنس فرغل دكتور.
Anas. Now, zeta greater than 1. This means that omega d is complex, yes or no?
ايش هي
دكتور مرة ثانية بس.
Okay. Zeta greater than 1, yes or no?
greater
دكتور 1
or less than 1?
مش كومبلكس
دكتور لا.
مش complex. So 1 minus 1.06 equal to what? Can you evaluate this one if in case of zeta equal 1.061? Can you evaluate this one? Can you plug this one here? Do you need a calculator to figure out that the root will be negative here? This value is greater than 1. This value is greater than 1. So if I square it, any value greater than 1, if I square it, it will be greater than the value itself, correct?
راح يطلع كومبلكس صح.
So if the frequency is complex, this means that it's impossible in physics. Can you see a complex frequency?
لا.
So simply this means that TB is infinity. Why? Because this one is undefined. Yes? So TB is go to infinity, correct? Yes? Yeah? The same thing if I need to calculate the percent overshoot, it will be what? It will be what? Now, if I plot this one here, I'm having the error signal or I'm having the response, which will go from here to here. Okay, it will reach the maximum value at infinity. This is the mean, huh? And the maximum value in this case equal to what? In this case, the maximum value is y steady state, correct? Yeah? Yes? Now, do you remember when we defined the overshoot? It was what? The overshoot was y at TB minus y steady state, correct? Yes? So y at TB is y steady state minus y steady state, so this would be 0, correct? Yes?
Yes.
Okay. Someone will say, I'm not convinced. Let's do it by hand, which means that I will calculate TB according to the differentiation. Huh? Do you remember when we need to find TB? I need to differentiate dy by dt and evaluate at t equal TB, and this must equal to what? To 0, correct? Yeah. Now, if I differentiate, I will get dy at dt at t equal TB. equal to 1.5 exponential of minus TP, or this one, I think 0.75, correct? Where is it? I need to differentiate this one. Huh? This 2, so yeah, it will be 1.5. Yeah, that's correct. So it will be 1.5 exponential of minus 2 TB here. Okay. And this will be the minus, and I'm having plus 1.5 exponential of minus TP. This will equal to 0. Now, if I simplify this equation, I will end up with 1.5 exponential of minus TP is equal 1 minus exponential of minus TP equal to 0. Now, مشاغبة موجود؟ رزق المشاغبة. No? سعيد أمجد زيدان. محمد الشرش. مهند إياد. No? طلال الشرع. Okay, that's good. محمد نضال. Fantastic. طارق سامر. Okay. أحمد محمد الرزاق. Okay. أحمد. This equation is equal to 0 if and only if what? Can you evaluate this?
Infinity 0.
One more time.
لما تكون t equal infinity أو 0.
Yes, which means that the first one, either this one is equal to 0.
أو اللي بين قوسين.
Or this one is equal to 0, correct? Yeah, thank you. So from here, either exponential minus TB is equal to 0, and this implies that TB is equal to infinity. And this, the first one we concluded from where? From the closed loop solution, correct? TB equal to infinity. Or
مو لازم 2 سالب 2p.
which one?
1 minus exponential minus 2tp.
This one I multiplied here. So this one is this one for this one, and this one for this one. Can you see it? If I evaluate, this will be 1.5 exponential minus TB minus 1.5 exponential minus 2TB. Yeah? You know that exponential of x multiplied by exponential of x is equal to exponential of 2x. Yeah?
Yes, yes.
Okay. So from here, we reach TB equal to infinity, and this is correct. What about if the 1 minus exponential minus TB is equal to 0? This implies what? That TB is equal to what? To 0. And this is impossible. Why? Because in general, TB is greater than 0. Yeah? Do you know the meaning of TB equal to 0 is what? This is the B and it is. And this one is impossible in physics. It's impossible. Yes? So what we are reaching, if I evaluate the math, dy by dt, I will get the same as if I use the closed form solution, except that here you should look that I don't have any zeros here. Here it just, again, this one just KDC. If I have a 0, this is another scenario I will discuss with Dr. Saleh if we need to discuss that with you or no. So I will skip this point here. Okay, now what about if I need to calculate the settling time? And for that, I will use another example. For that, I will use the following example now. Or let's discuss it. Let's challenge ourselves here. So, example, let's assume that I'm having the following transfer function y over r equal 3s plus 2 over s plus 1 s plus 2 and I need to find the TP, the percent overshoot, and the TS. So I need to find the peak time, I need to find the percent overshoot, and I need to find the settling time, of course, in the unit step response, in the unit step response. Now, here in this example, n of s equal to what? In this example, n of s equal to what? And let's see, Ahmed Hamad.
نعم دكتور.
Ahmed. So n of s equal to what?
3s plus 2.
Yeah, thank you. So this is called n of s, and this is called d of s. So here I'm having n of s, which equal 3s plus 2. So simply here I'm having 0, huh? I'm having 0 where at s equal minus 2 over 3. Yes. So in this case, this system is called non-standard second order system. So in this case, this system is called non-standard second order system. Why? Because I'm having a 0 in the system. This is called non-standard second order system. So in this case, the 0 actually has effect on the transit response. So it will change slightly. It will change slightly the peak time and the rise time and the settling time. And for that, I will evaluate the two things using our closed form solution here, using the standard second order system relation, which states that, for example, TP is equal pi over omega d, which states, for example, that TS is equal 4 over sigma, yeah, which equal 4 the time constant, and which also states that the percent overshoot is equal exponential minus zeta pi over square root 1 minus zeta square 100%. Now, and I will evaluate it using what? Using the mathematical evaluation. Yeah. So the first thing I need to find y of t here. Y of t will equal the Laplace inverse of y of s, and if we do the partial fraction expansion for y of s, it will read as 1 over s plus 1 over s plus 1 minus 2 over s plus 2. Now, this I need to have the Laplace inverse for the first one, the second one, and the third one. If I do that, y of t will equal to plus exponential minus t minus 2 exponential minus 2t. Okay. Now, the first thing here, I need to find y of t. So what I need to find y of t, TP, I need to evaluate dy by dt at t equal TP equal to 0, and this will be, if I evaluate, minus exponential minus t, then this will be plus 4 exponential minus 2t. Now the same thing, if I need to solve this one, I would say that let x equal exponential minus t. So I will end up with very simple equation to be solved, equal to 0. And from here, either x is equal to 0 or I'm having x equal to 1 over 4. So if x equal to 0, this means that exponential of minus TP is equal to 0. And this means that TP is equal to infinity. Yeah. Now, the second one, if I choose x is equal 1 over 4, if I evaluate exponential minus TP equal 1 over 4, this will give me that TP
1.38.
Thank you, 1.38 something, huh?
686.
So if I need the 3 digit, this will be 39, huh? Because it's 1.386. This one is higher than 5, so it will be here approximated, huh? This is should be respected. Raha.
Yes.
Thank you. Okay. So this is actually the TB. Now, why I swing out this one? TB is equal to infinity. Simply, if I have 2 TB and we defined, do you remember we defined what? We defined the peak time as what? At the time at which the response peak at the first time. So it peak here, correct? So this is the first peak, yeah? The first peak. So I will consider this one, the first peak. Okay. Now let's see. If I'm using here TB is equal pi over omega d. If I evaluate this one, what it will give me? This will give me infinity, correct? Yes. Why? Because the system is what? Critical or underdamped or overdamped?
Overdamped.
Why? Because the roots are negative, real, and equal, correct? Or if I need to calculate zeta, it will be greater than 1 actually. But I don't need to do that. I can find it from the roots, correct? I know that if the system is critical damped, then the roots are equal negative. If the system is overdamped, then the roots are real, negative, and equal. If the roots are complex conjugates with negative real part, then the system is underdamped. If the roots are pure imaginary, then the system is underdamped, correct? Yes? Yes. So see, this one will give you misleading information. Why? Because I'm having another time where the response is peaking at the first time. But do I have oscillation, by the way? Do I have oscillation? No, I will not have oscillation, but the system will peak. The system will peak without oscillation. How is that possible, by the way? Simply, let's assume that this is the DC gain here is equal to 1, correct? Yeah, I think the DC gain equal to 1 because it's 1, yeah. So simply if I plot the response, it will be something like this. The system will reach a peak at certain point, then it will settle down without oscillation. Now this one here at T is equal 1.39. And if I need to find this value, it will be what? Y at 1.39. I can substitute and I can evaluate, and this will equal 1.12. Okay. Now, who can give me the percent overshoot equal to what? The percent overshoot equal to what? Do you remember the percent overshoot is what? Y of TP minus Y steady state over Y steady state, and simply Y steady state is equal to 1. YTB we already calculate there. So this will equal 1.12 minus 1 over 1. Yep, multiply by 100%. So this will equal 12%. Yeah. Good. Okay. Okay. Now, if I need to calculate the settling time, or before calculating the settling time, do you think the settling time is greater than TB or less than TB? And this is TB, yeah? Now, if I need to calculate the settling time, do you think that TS is greater than TB, or TB is greater than TS, or TS is equal TB? And for that, let's say Lina Jawad. Not there, huh? Abdullah Al-Khasawni.
معك
Amara.
دكتور.
Abdullah Al-Khasawni. Abdullah.
معك
Now,
دكتور.
okay, thank you, Abdullah. Now, do you think, Abdullah, what's the relation between the settling time and the peak time? Is the settling time greater than the peak time? Or the peak time is greater than settling time? Or they are equal? And why, of course? And I will give you 1 point for that. I will give you 2 points if you justify your answer. 3 points.
اوكي.
4 points.
عايز دكتور هو السيتلينج تايم هو احنا قلنا المحاضرة الماضية انه هو التايم لحد ما اخر مرة انه يعني تفوت على البيك وما بيطلع منها مرة ثانية، او اللي هي البوينت او 2 الزيادة، فاتوقع انه بيقولوا متساويات.
متساويات. So Abdullah said that TS is equal to TB, and this is not correct. So I'm retreating my 4 points, and now there's no points. Now, see, this one is what? This one here is what? This one is 1.12. So for sure, TS will be after that. Why? Because TS must be in a place where the system is entering at 1.02, correct? Yes.
Yes.
So simply in this case, this is the TS, and of course the TS is greater than TB in this case. Yeah? Yeah. So this is only, let's say, a way in order to check your answer later on if you calculate the TS. So now let's calculate TS. How to calculate the TS? The settling time, how to calculate it? Abdullah, you are with me, correct? Settling time.
ناخذ 2 بوينتس دكتور، كنا على الواي اللي هي واي اوف تي بتساوي 0.1 من الواي سي ستيت و 0.9 نطلع تي 1 و تي 2.
No, just a minute, just a minute. Now this system will never reach the 0.9. Why? Because this system has no oscillation. Correct? Why this system has no oscillation? I'm not using dark magic. Simply the roots are real. So if the roots are real, impossible to have oscillation. The oscillation is connected to the complex roots, correct? To the imaginary part in the roots.
Yes.
The sine and the cosine is triggered because I'm having imaginary part in the root. But now my roots are what? Real, negative, and equal. So simply impossible to oscillate. I'm having peak. Yes, I'm having peak. Why I'm having peak? Because I'm having non-standard second order system. I'm having zeros in the denominator. So I will peak, but I will never oscillate. So simply this means that the response will never get out from the boundary of this one at any time. So it will enter here at TS and stay there forever. It actually will approach what? It will approach this state. It will never oscillate. So here what I'm having only one possible scenario, which is 1.02 y steady state. This is the point here I need to calculate. This will equal 1 plus exponential minus TS at this point, minus 2 exponential minus 2 TS at the same point. And now if I evaluate what I'm getting, I will get minus 2 exponential minus 2 TS plus exponential minus TS. And if I collect the terms, and y steady state equal to what? Y steady state in this case equal to what? 1, huh? Why 1? Because the DC gain is equal to 1. And the input is what? Is unit step. So this will equal minus 0.02 equal to 0. Now the same thing, now I need to do a change of variable, exponential minus ts equal to x. So I will end up with what? Minus 2x squared plus x minus 0.202 equal to 0. Raha, x equal to what? Raha is my calculator. Raha, can you calculate that for me?
Okay, but give me 1 minute, Doctor, please.
Okay.
Um, 0.48.
So 0.48.
Yes.
Okay.
0.02.
And 0.02. Yeah. According to Raha, those according to Raha, if I'm writing your name correct, and let's capitalize that R. Okay. So if you have problem, consult Raha. I have no idea about that. Okay. So from here, Raha, TS equal to what? And from here, Raha, TS equal to what? And thank you for your help, actually. You know how to evaluate. I will evaluate from here. I will say that x, I will say that t is equal minus ln x. Okay. So the first one.
0.734.
Okay, the second one, TS here.
3.9.
3.9 seconds. Thank you, Raha, and you will have +1. So this is +1 for Raha. And remember to tell me that, huh? +1. Okay, Raha. Now, Raha, in order to deserve the one, which one I will select? TS, the first one or the second one? And why?
The second one,
Why?
because it has to be more than TP.
Thank you. And you will get another point. So now you will get in what, 2. Okay, remember me to add that, huh? Thank you, Raha. So which one I will select? The second one here. Why? Because simply TS must be greater than TB. Why? Because TB actually is greater than 0.02. Yes? Yeah? Good? Good. Now, let's assume I'm having the following example. And I will give a lot of points, actually. Yeah? Another example. I need you to plot the region in the S plane such that okay, let's make it simple in the first case. Omega n is greater than or equal to 2, less than or equal to 4, and zeta greater than or equal 0.3, less than or equal 0.8. Of course, I can link it with what? With percent overshoot and time constant. So simply, this is the S-plane, this is the real, this is the imaginary. Yeah, and I need to mark or plot the region in the S-plane such that omega n is greater than 2, less than 4, and zeta greater than or equal 0.3, less than or equal 0.8. Okay. Now, omega n, how I can do that? Do you remember the roots? The roots in this case S1, 2 is minus sigma plus minus j omega d. So one will be here and one will be here, correct? Now, if we do the math, we know that this one from here to here. Okay, so let's make it perfect. Huh? Those must be in the same, on the same line. Now we know that this point from here to here is sigma, and this point from here to here is omega d. So if we do the math, this will be what? Omega n, correct? So simply here, what I'm having, omega n equal to 2, so this one is 2. And this will be the minus 2. Omega n equal to 4, this will be the 4. And this will be the minus 4. Then what I will do, I will plot a circle. Yeah. Yes. So now this area here, or this space here, is correspond for what? Is correspond for the first condition. Yeah. For omega n greater than 2, less than or equal to 4. What about the second condition? What about this one? And for that, let's choose Ammar Alauna. Ammar. Muhammad Zaid. Aus. معايطة. يوسف العمري. عبد الله العمري. سيف أبو جسار.
نعم دكتور.
سيف. Thank you سيف.
أهلين دكتور، إيش السؤال بس مرة ثانية؟
أنا أحط إيدي على السؤال تلاقيني في الريرة. فين السؤال بقى؟ This is the question. Now, what I need you to mark in the S-plane the area or the region that fulfill or obey the following relation: zeta greater than or equal 0.3, less than or equal 0.8. We did that for what? For omega. So how I can do this one? Now,
زيت كيف ألاقي زيتا يعني؟
لا, zeta is given. Huh? Zeta is given. I'm giving you zeta. Zeta is given. Zeta in this range. Okay. Now follow up with me. Now what I need to find this angle. Theta.
بوجد الكوساين.
Okay. So this angle theta equal to what? Do you know that theta equal to what? It's tan inverse of the imaginary over the real, correct? Yeah.
صح.
And the imaginary is what? Is omega d.
Omega d على sigma.
Over sigma. And you know that the tan is equal the sine over the cosine. Huh? You know that tan theta is equal sine theta over cosine theta. So from here we know that sine theta is equal to omega d, and cosine theta is equal to sigma. So now theta is equal to what?
Cosine العكسي للسيجما.
Sigma, yeah. And simplify, let's simplify it in terms of zeta and omega. So now I will get what? I will get theta, which equal tan inverse of omega d, which equal omega n square root 1 minus zeta square.
صحيح.
Over sigma, which is what? Omega n.
Omega zeta.
So according to the Bachmann theory, what will happen?
الأوميجا راح تأكل الأوميجا.
Yeah, So I will end up with what? I will end up with sine
zeta تربيع على
root 1 minus zeta square, and cosine theta is equal to zeta. So from here, theta is equal to what? Cosine inverse of zeta. Yeah. So simply, this is very simple. I need to evaluate the cosine and the inverse of those terms. Huh?
صحيح.
So now, in terms of theta, so this one is what? I need to say cosine inverse, or I need to find theta. Sorry, I need to find theta, huh? Because I'm giving you zeta. I'm giving you zeta, and I need to what? Find theta. Huh?
Oh.
Yeah. correct?
الكوساين العكسي لل 0.372.54.
Okay, so the first one, theta 1 is equal 72.
72.54.
Okay, and theta 2?
ثيتا 2 كوساين العكسي لل 0.36.86.
Thank you. So simply here I will draw two lines, correct? I will draw
صح.
two lines, one with angle equal to theta 1 and the second one with angle equal theta 2. The same thing here I will do. It must be symmetric. And this one is theta 1 and this one is theta 2. And this one is theta 2 and this one is theta 1, huh? Correspond to. So zeta here equal to what?
زيتا 0. شو اسمه 3.
0.3. Yeah. The small zeta. Are you sure? Cosine theta equal to zeta. Now, if this one is very small, zeta will be very large, correct?
صحيح.
Close to 1. This will be close to 1. Yeah?
Yes.
If the angle is close to 0, then zeta will be close to 1, correct?
صحيح.
Yeah?
صح.
So, this one is zeta 0.3, I think.
صحيح. 0.3.
And this one corresponds for zeta 0.3, and this one corresponds for zeta equal
0.7 أو 0.8.
0. Okay. Now, where's the range that I'm searching for? I'm searching the range that fulfill the two relation here. Where is it? The intersection.
الرينج يعني اللي
The intersection.
الانترسكشن.
Yeah, and you will get 1 point. اسمع.
شكرا.
انت safe? Okay, safe. So safe, you will get +1 and don't forget to tell me that.
لا لا.
You will need it actually. You will need it. Okay. So this is the area as Safe told us, and if you have any problem, please consult Safe for that. He is expert in marking, let's say, the region in the S-plane that fulfills certain, let's say, percent overshoot and certain settling time. Yeah. Good.
Good.
Good. Do you have any question until here? Until now, I gave 3 points actually, 2 for Raha and 1 for Safe. Who need also to receive points?
Me.
Me.
كلنا دكتور.
Okay, I will ask, answer. Yeah. Okay. Do you have any question before going to something almost related but slightly different? Okay. Now let's discuss until now what we have. Until now we can characterize the first order system and we can characterize the second order system. Yes, but you know that not all the system is first order system and second order system, correct? What about if I'm having a higher order system? For example, what about if I'm having third order system, fourth order system, and so on? What I should do in this case? What I should do in the case of the high order system? And for that, let's start with a simple example. Let T of S, the closed loop transfer function, which equal Y of S over R of S. And this one equal certain factor, let's say, omega n square, S plus alpha. And here I'm having S square plus 2 zeta omega n S plus omega n square. Now, if you notice here, I'm simplifying the thing for me. I already decomposed the system into first order system, correct? And second order system, yes? and also I maintain the DC gain to equal to 1. Yes? Why? Because, you know, I'm too old to do any math. So I need to eat a cheesecake, yeah, which is simple for me. So now let's see. We know how to analyze a first order system because the first order system is characterized by a DC gain and time constant. And we know how to characterize the second order system. Why? Because it's related to zeta and omega n, correct? So in this case, what I should do? Someone will say, if you have higher order system, expand it into what? Into a simple systems, either first order or a combination between first order and second order, correct? So now let's see. And for that, let's assume that zeta is greater than 1 less than 0, only in order to write the closed form solution in certain form. So let's assume that zeta greater than 0 less than 1. So here, who can give me the roots equal to what? You know this one is equal n of s over d of s, and the characteristic equation is d of s equal to 0. The solution of the ds equal to 0 is the roots of the characteristic equation, which are the powers of the transfer function. So here, who can give me the roots?
Minus alpha.
Of the characteristic equation, which is the solution of d of s equal to 0. Yeah, thank you, Raha. So the first one, s equal to minus alpha, and the second two?
Minus sigma plus minus j wd.
That's why here I'm using what? This one assumption in order to evaluate the root. Huh? So I need minus zeta omega n plus minus j omega n, the square root of 1 minus zeta square, or as Raha told me, it can be written as minus sigma plus minus j omega d. Yeah. Now, if I need to evaluate the solution, who said that I need a point? مين بده علامة؟
أنا.
مين أنت؟
كلنا دكتور.
لا، ما هو واحد يعطيني اسمه.
مراد.
مراد يا مراد. مراد. Y of t equal to what? In order to get that. Y of t. مراد. مراد أحمد؟
نعم.
Y of t equal to what?
نعمل لابلاس انفرس.
Give me that.
هلا بدنا نضرب ال T of S في ال R of S. ونعمل لابلاس انفرس.
طيب يعني
تمام.
So, no, I need by the way, I need the form. Huh? I don't need the exact number. I need a form for that. So can you tell me that, Murad, and you will get 1 point. Now you know that this is what? This is a higher order system decomposed of first and second. So if I do the partial fraction expansion, I will end up with what?
ال S بلس ألفا راح تكون بالمقام مع اللي هم الجذرين تاعون المعادلة التربيعية.
So here I'm having certain K, yeah,
K.
and here I'm having certain N1 over
Yes.
S square plus 2 zeta omega n plus omega n square, and here I'm having some polynomial, huh?
Yes.
That's it? Huh? Is it enough?
No.
Then what else?
هلا ايه؟
What else I'm having?
هلا الأولى هلا الثانية بدنا نفصلها برضو تصير عندنا ثنتين.
What I'm having here?
Here KE2 minus T alpha.
This one is only for this root and this root, correct? Remember, the unit step response, you will add S to the system, correct?
Yes, I said that.
Here I will have K2 over S. Yeah?
حكيت لك بنضرب ال R of S فوق عشان تصير ال Y of S فبتصير 1 على S وبنطلع K.
So here what I should write?
K2.
Which is equal to what? K2 equal to what?
كيتو هلا بدنا نطلع شو اسمه، بدنا نضرب الاس في التيرم الاساسي ونعوض محله صفر وبتطلع معنا الكيتو.
Weiss, can you give me K2 equal to what?
طب أنا أقول لك يا دكتور إيش هي؟
Yeah, K2 equal to what?
1.
ليش؟
إنه عوض صفر تطلع 1000 أوميجا سكوير على 1000 أوميجا سكوير.
Because the DC gain is equal to 1, yeah? Yeah. Then, here what I'm having, certain gain I don't care about. Here I'm having K exponential of minus alpha T. And here I'm having another term, let's say K3 exponential minus T sine, or here I'm having sigma minus sigma T minus, and here I'm having omega dt plus certain angle, correct? This is the general form, yeah? Now I don't care about this one and this one, by the way, in this case. What I'm caring about this one and this one. The order of magnitude, or the relation between the first root and the real part of the second root, okay? Now let's see. Let's discuss the following scenario. The first scenario, let's assume, assumption, let is equal to 10 and sigma equal to 1. So y of t in this case equal to 1 plus certain k exponential minus 10t plus certain k, I don't care about, exponential of what? Minus t sine omega d sine omega dt plus certain angle. Yes. Now, which one decay fast? Which one decay faster? This one or this one? الأولى. Why?
عشان التايم كونستانت تاعها أصغر.
Yeah. So the time constant here is what? 10 times faster than this one, correct? So simply this means that which one will decay faster? This one. So almost I can assume that this one will go to 0. But this one is still there. Yes?
Yes.
So this means that y of t can be approximated to be 1 plus a, another gain, exponential minus t sine omega d t plus phi. Correct? Which means that all the response is characterized by the second order system, not the first order system. Yes? Yeah? So in this case, the first order system is called non-dominant. And the second order system is called what? The dominant. Yes?
Yes.
Good. So now, safe. Now, safe. I will give a point if you answer. Huh? Now, this means that the transfer function now can be approximated to be what?
الانبوت هو هذا ستيب ريسبونس.
T of S, this one is equal y over r. Now, yes. This one can be approximated to be what?
1 over S.
Now, you said that it's characterized by the second order system, huh? So here, what I should write?
هنا 1 S تربيع.
Yeah. Okay.
2 ضرب 1 يعني 2. احنا اوميجا فوق هي تساوي شو اسمه 1 قصدي سيجما عشان سالب تي. دبليو يعني بنجيب بعديها الدبليو ان تربيع من دبليو ان تربيع تساوي 1 تربيع زائد دبليو تي دي تربيع. WD صح؟ إنه
no.
سيجما فوق.
sigma
إنه
where هون what I should put here.
لا اللي جنب E سالب T هون WN تربيع.
This one, yeah, this one sigma because it's characterized by the second order system.
هسا بتصير هي كالتالي WN تربيع على S تربيع زائد 2 زيتا WN S زائد WN تربيع.
What I should put here?
إيه
Here.
WN تربيع.
Here I should put تربيع. Why?
لأنه هون الواي ستيدي ستيت واحد يعني.
And the steady state value. Now, do you see what I'm doing here? I'm only modifying the transient, but I'm not touching the final value. If I'm approximating a system, it will change the final value. No, the final value are the same, except that I'm modifying the transient. Here I'm saying that the transient is only can be characterized correctly by the dominant system, not the non-dominant system. So in this case, I should maintain the DC gain to equal to what? To equal 1, correct? To equal to 1. Okay. And your name is Yusuf Isa?
سيف.
Huh?
سيف أبو جسار.
Safe. What is it? Safe. Okay, safe. Okay, safe. Oh, okay. So now you are getting 2, huh?
تمام دكتور شكرا.
Okay. Good. So now this is the approximate second order system that can represent the third order system. Now, what about if we have a reverse scenario? Alpha equal to 1 and sigma equal to 10. In this case, what I'm getting, in this case, y of t is equal 1 plus k exponential minus t plus k3 exponential minus 10t sine omega d plus phi. Now, which one is the dominant? Which one is the non-dominant here? This one's what?
الأول dominant الثاني non-dominant.
Yes. Why? Because this one will vanish very faster, 10 times faster actually from this one. So simply this means that y of t can be characterized to be 1 plus certain k, let's say k4 exponential minus t. Yeah. So simply this means that it can be 1 plus k4 exponential minus alpha t. So if this is the case, then y over r, which equal t of s, this can be approximated to be certain gain here, k, or let's say before that. Here already I know it will be s plus alpha. Yeah, it here will be s plus alpha. And here what I should put? Alpha in order to maintain the DC gain equal to what? To 1. Yes. So the same thing here in this case, we are saying that S equal to minus alpha is the dominant root, and S which equal minus sigma plus minus j omega d is the non-dominant. Yeah. Now, in general, I need to set a value for dominant and non-dominant. Otherwise, any system will be, let's say, approximated to a first order system. This one we will discuss it later on in the next lecture. Now, do you have any question?
دكتور شو بالنسبة للامتحان بكرة كيف النمط
لا كيف النمط؟ It's a typical example. It's a typical example. It's a one-way example, sequential example. Consists almost, let's say, 28 part, and each part can be solved with no time. Such guys just plug and play if you understand the material. Some need to be calculated. Some you can figure it out if you understand the concept of the material. So study hard, do your best, and we will see what will happen after the exam. Okay?
دكتور راح نرفع اشياء على الليرنينج ولا كله فاينل انسر؟
No. You will select. It's drag and select. It's like a multiple choice, not ABC. It's a menu will pop and you will selecting, let's say, a list. From the list, you are selecting what? You are selecting your answer. Okay. And if you finish a question, you cannot return back to the question. How many answers?
يكون في كثير حاطين.
It depends. Sometimes 7, sometimes 5, sometimes 8, sometimes 9, according to the question. So you don't need to think about it. Just let's say study hard, trust yourself, and use your calculation. Don't take any answer from another one. It will be very dangerous, actually. Good. So do you have any question regarding today's lecture? Do you have any question regarding the midterm material? No?
دكتور كم سؤال الميد؟
You know that we have a main question and we have sub questions. Yeah. For example, in this lecture, I wrote or we discussed, let's say, example where I can calculate, for example, rise time, peak time, percent overshoot, settling time, correct? Zeta, omega n, error, steady state. So 1 with 10, yes? So simply, let's say with a multiple choice, it will be around 27, 28. Understood the meaning?
تمام.
Question related to that one. From those, more than 50% of the question, I think, can be answered with no time, which means that it's just only a concept, your understanding, and how much you understand the control theory. Okay?
تمام دكتور يعطيك العافية.
يعني دكتور بنفس الصفحة بيكون طالع عندي 3-4 أسئلة متعلقات بنفس السؤال الرئيسي بيكونوا.
Yes. Each main question contain its own page, let's say.
دكتور الأسئلة لها نفس العلامات كلها ولا في مثلا سؤال بيكون عليه 5 10؟
Each part has the same weight, each part. So if I'm having question with 10 parts, it will weigh 10 times a question with a single part. Understood?
So,
it's like a typical control exam, sorry. Yeah. So study hard, you need to do that. And best wish. So best wishes for you for that until tomorrow. Keep distance, stay safe, and see you tomorrow inshallah. يعطيكم العافية. السلام عليكم.
وعليكم السلام دكتور.